right. Good day, everyone. Thank you for joining us for the Canadian Underground Infrastructure Innovation Centre Academy webinar on pipeline integrity management at ATCO. My name is Jason Luke. I am the chair of the CUIIC Education and Outreach Committee and be your moderator for the day. And my day job is the National Discipline Leader for Trenchless at Associated Engineering. So again, thank you very much for joining us here today. The CUIIC Academy, these are organized by the Canadian Underground Infrastructure Innovation Centre and the University of Alberta, and in partnership with Benjamin Media. And what CUIIC does in the CUIIC Academy is they offer classes, courses, webinars, and other events to help further underground infrastructure, educational opportunities across Canada. Our Academy webinars, which you're joining us here for today, we try to cover a variety of topics, pressing issues related to underground infrastructure in all sectors of underground infrastructure. The speakers we have include industry-leading professionals who provide a free educational webinar to the public, followed by a question and answer period. So as we're going along, if there's any questions, you should be able to put the questions in the question box in the bottom here. And at the end of the presentation, we'll have a Q&A session. So by all means, during the presentation, please enter any questions you may have. We have these monthly on the third Thursday of every month at 10 a.m. Mountain and 1 p.m. Eastern. And to see a full schedule of the events, of CUIIC events and webinars, please go to the CUIIC website. And all past webinars are available on CUIIC's YouTube channel. So if you miss anything or you want to go back, by all means, go take a look. In 2026, CUIIC, we've already put together 2 events. We're calling them summits, and these will be 3-day events. We'll have one in Mississauga here in March, and one in the fall in Vancouver, just finalizing things there. And these will be 3-day events where you can choose to attend all 3 days or individual days. For instance, in March, the topics will have a geotechnical kind of workshop on day 1. I think it's microtunneling on day 2 and directional drilling on day 3. You can come attend all 3 or just one individual days. That's part of, it's up to you, to the attendees, but those will be the 2 main events coming up here in 2026, in addition to our monthly webinars that will be continuing. As always, we give a big thank you to Ackerman. They are sponsors for our 2025 webinar series, so thank you very much, Ackerman, for being a sponsor this year. And now we'll do a brief introduction on our presenter today. Brendan Eirich is the senior engineer on ATCO's Pipeline Integrity Projects team. He spent the first 2/3 of his 11-year career managing integrity projects of varying scope and complexity, including inline inspection and integrity digs on ATCO's gas transmission system. He used what he learned from his training and project work to build up an extensive technical knowledge of integrity management practice. Brendan moved into a senior technical role and now is responsible for providing support to integrity project managers, developing department program and technical standards, and mentoring the next generation of pipeline integrity engineers. He holds a Bachelor of Science in Materials Engineering from the University of Alberta and is a registered professional engineer in the Province of Alberta. Brendan also has been a musician for nearly 30 years and is an avid fan of German cars. So Brendan, welcome. Looking forward to your presentation, and I'm turning it over to you.
Great. Thank you, Jason. And thanks everybody for attending today. I'm really looking forward to sharing sort of the strategies and the ideas that we work through every day on ATCO's gas pipeline system with regards to pipeline integrity. So kind of start with a bit of an agenda today. I'm going to start by giving a brief overview of sort of ATCO's natural gas system in Alberta. We'll move on then to the general goals of a pipeline integrity program and sort of how ATCO's pipeline integrity program functions within those goals. And then we'll start talking about how pipeline integrity considerations are integrated into the different phases of the pipeline life cycle. So we'll talk about it briefly for new pipelines. We'll talk about it for existing pipelines during their operational stage. And then we'll talk about it for pipelines that are approaching their end of life, or in some cases at the end of their life. And then finally, I'll conclude with a couple of key takeaways, and then we'll move on to the questions section of the presentation. All right, so starting with ATCO's system. So ATCO provides natural gas service to about 1.3 million customers in Alberta across over 300 communities. ATCO's service area covers almost all of the major population centers within the province. We service all manners of gas customer, from individual rural homes via farm tap units to major cities like Edmonton and Calgary, as well as large industrial installations such as the Industrial Heartland and various power plants, through approximately 9,000 kilometers of high-pressure transmission pipelines and 55,000 kilometers of low-pressure distribution pipelines. In Alberta, natural gas has become a critical resource, not only for surviving the harsh winter months, but also for contributing to the economic growth of the province. To ensure that customers have a safe and reliable source of natural gas for their energy needs, ATCO must ensure that the system is continually operating at its peak. To do this, pipeline integrity is at the forefront of ATCO's operations for the lifespan of its assets, from new pipeline design and construction through its operational life to its final decommissioning. Today's presentation will focus primarily on the integrity management program for the high-pressure system, which is almost exclusively comprised of steel pipe, but many of the same integrity management goals and practices apply to the distribution system and pipe made of other materials such as plastic or aluminum. So, as a pipeline operator, ATCO is required by the governing code, CSA Z662, Oil and Gas Pipeline Systems, to have an integrity management program in place. Pipeline integrity at ATCO is driven by a series of key goals, all with the purpose of ensuring that natural gas gets from producer to consumer with no incidents. These goals include the creation and use of high-quality, resilient design standards. One of the first lines of defense for a gas pipeline system is how it's designed. Standards that promote appropriate safety factors are a great start, but standards that promote those safety factors while considering things like maintenance work and the impact of real-world threats the asset could face over its lifetime are even better. More of these factors that are addressed in the design, the better equipped the pipeline will be to handle changes to its surrounding environment for decades. Next up is incident prevention. Knowing details about the pipeline's operating conditions, its local environment, things like the soil it's buried in or geological formations that it passes through, can be valuable in identifying where threats to the line's integrity can come from and putting measures into place to effectively mitigate them before they can cause harm. This information factors into the design process for new pipelines, but it can also be useful when managing existing assets as well. And finally, early threat detection. While prevention is always the best option for managing threats to a pipeline, we have to remember that these assets operate in the open world, meaning that they can be exposed to the elements and to damage from human activity, whether intentional or unintentional. While high-quality design and incident prevention measures are a good way of minimizing the potential for incident, they're not perfect. As such, there's a need to monitor a pipeline for activity that threatens the integrity over the course of its regular operation. A good pipeline integrity program has methods and activities to detect these threats early before they pose a threat to the supply or public safety. At ATCO, these three driving program goals work in tandem to minimize the likelihood that a pipeline failure occurs. These goals are codified into ATCO's transmission and distribution pipeline integrity management programs, documents which are meant to act like charters for accountability and continuous improvement, supported by company leadership. These programs form the foundation on which the integrity management process operates, and they give the integrity team the authority to make decisions to take appropriate action in the service of ensuring continued safe and reliable system operation. Now, as we move to the next sections, you'll begin to see how these three goals influence ATCO's pipeline integrity mentality at each stage of a pipeline's life cycle. Let's start at the inception of a new pipeline project. Pipelines are often constructed to meet changes in demand, or to replace aging assets, or to bring gas to new customers in new geographical locations. Before construction on a new line can begin, a comprehensive design process must be undertaken to ensure that the pipeline meets the minimum requirements of the code, it is resilient enough to withstand exposure to the elements, and that it can be practically maintained over the course of its life. In this section, we'll cover how the requirements of the Integrity Management Program are integrated into the design, construction, and commissioning phases of a new pipeline project. New pipelines present arguably the best opportunity to incorporate proactive integrity management practices. When new pipelines are in the design stage, ATCO considers how elements like physical pipe attributes such as diameter, wall thickness, or coating, routing, such as avoiding geohazards or managing population density or the proximity of third-party infrastructure, and line operation, such as pressure, ongoing maintenance, or customer demand, could change the way as the pipeline is built, influencing design safety factors that help make it less susceptible to the unique integrity threats that it will encounter along its length. ATCO's pipeline system is required to be designed in accordance with CSA Z662, as I mentioned before, which outlines the minimum design standards. This means that for ATCO to produce high-quality, resilient design, it must meet the minimum requirements of the code, while also addressing its own risk tolerances and allowing for long-term, cost-effective integrity management. Much of the integrity work done in this phase of the pipe life cycle is aimed at prevention and is based on the principles of risk mitigation. In this case, using common strategies like elimination, substitution, engineering controls, and administrative controls to reduce the likelihood or consequence of integrity threats by making changes to the design. Much of the risk mitigation in the design phase centers around the use of elimination and substitution to optimize that design. For example, certain pipeline coatings may perform better in rocky soils and should be used over coatings in areas where such soil conditions are expected. In addition, population density plays a major role in determining the design requirements, as it directly impacts the minimum allowable safety factors that influence things like allowable operational pressure. Pipelines in high population density areas typically have higher consequence of failure and will be designed to significantly higher standards to increase their resiliency. The final design in this case, then, is one that meets the minimum requirements to contain natural gas at the desired operating pressure, ensures that the line is less susceptible to integrity threats over the course of its operational lifespan, and can be easily maintained and repaired. It's at this point, then, that the pipeline is ready to move to the construction and commissioning phase. The construction and commissioning phase of a new pipeline project is fast-paced and intense. Despite this, safety and quality are still top priorities. Every aspect of construction, from material manufacturing and transportation to installation to as-built documentation, is driven by the requirement to maintain high quality and traceability. ATCO utilizes engineering and administrative controls heavily in this phase of the project to manage these requirements. Typical engineering controls include things like design drawings and job procedures, which outline what is to be built and how. Administrative controls include many of ATCO's internal standards and policies designed to maintain consistent safety and quality during the construction phase. Controls that are tied back to pipeline integrity include things like our backfill standards, our weld inspection policies, project documentation requirements, as-built specifications, and many more. In the United States, the Pipeline Hazardous Materials and Safety Administration, or PHMSA for short, outlines these requirements using the phrase traceable, verifiable, and complete, or TVC. In Canada, while this requirement isn't explicitly stated, ATCO does aim to achieve this level of documentation for all new pipeline construction. Prior to operating the pipeline, ATCO undergoes several commissioning processes aimed at achieving two integrity-driven goals. The first one being the verification of construction quality through field testing, and the second one being the establishment of a baseline pipe condition for comparison during future inspection activities. In more detail then, the final tests here then for ATCO's high-pressure pipelines at the field testing level is the completion of a hydrostatic pressure test. This test involves pumping water into the pipeline and pressurizing it to a point higher than the maximum operating pressure of the pipeline. This test is considered successful if the pipeline can hold that pressure for at least 8 hours. If the pipeline can maintain this pressure without incident, then no existing construction or material flaws present at the time of the test are expected to fail under normal operation. Next up is that baseline pipe condition. So establishing that baseline pipe condition is also important since it provides a data set that acts as a point of reference for future inspection activities to compare against. ATCO typically achieves this by running inline inspection or ILI tools that can detect and measure anomalies like metal loss or deformation at very high resolution, often down to the millimeter scale. The same tools are then run periodically over the course of the line's operational lifespan, and we'll touch more on that in the next section. Now, all of this talk of construction quality doesn't really sound like integrity work, but construction quality and traceability are critical as the asset transitions from the construction phase of its life to the operational phase. Having confidence that a pipeline was built without flaws that could fail in the future, and being able to reference complete documentation for maintenance activities years or even decades after construction is essential in ensuring that integrity decisions made over the course of the line's operational life are well informed. So, we've built the pipeline, we've commissioned it. Welcome then to the operational phase of the pipeline life cycle. This is where our assets spend almost all of their time. During the previous phase of the pipeline life cycle, the integrity team acted mainly in an advisory role, doing our part to ensure that the design and construction of the pipeline made it resilient and ready for the transition into ongoing operation. It's here in the operational phase that the integrity team moves into a much more active role, executing the integrity management program that monitors the assets for change, identifies and prioritizes threats, and takes necessary action to prevent that pipeline from becoming a risk to public safety or to supply reliability. In this section, we'll explore the various ways that ATCO manages operational pipelines, including a high-level review of the structure of ATCO's integrity management program, some of the tools at our disposal to monitor change and identify threats, and when and how we act when threats become unacceptable. We'll also explore how ATCO's integrity team manages uncertainty, something that becomes particularly important when we're dealing with older assets. Let's start quickly by going over how ATCO's organized its transmission pipeline integrity management program. Note that while the structure and the underlying intent of the program are meant to apply across the entire pipeline lifecycle, most of the program's activities occur in this phase, the operational phase. ATCO divides the specific activities within this program into a set of 19 subprograms, which you can see on the screen. Each of these subprograms is meant to address a specific risk or threat to the pipeline, and most involve some form of inspection, survey, or assessment to measure the pipeline and generate information about its current state. This information is then used by that subprogram to identify potential threats, determine their priority level, and recommend actions to mitigate them. These subprograms do not, however, operate in isolation. In fact, the greatest value generated by the integrity management program is through the interactions between subprograms. It's not uncommon for data generated by one subprogram to be used by another, so it's crucial that ensuring data generated by each subprogram is freely available. For example, the manager of the watercourse management subprogram might look at inline inspection data generated by the ILI subprogram to get a better sense of the condition of a pipeline at a river crossing. In turn, that same program manager could conduct a survey on that crossing and note that a high stream flow event may have exposed the pipe in the riverbed. They could then recommend that the next ILI on the pipeline use tools to map the three-dimensional path of the pipe and see whether it has moved in the river channel, an event that could put excessive strain on the pipe and could potentially require some form of repair or remediation. The common theme among these subprograms is they're all intended to monitor the pipeline, and when they're functioning correctly, they collectively serve as a sort of early warning system. I'll note that this means that most of the actions taken by the integrity team during the operational phase of a pipeline's life cycle are reactive. The integrity program monitors for change and then acts once that change is detected. This is different from the previous phase of the life cycle, where mainly proactive integrity managers in the form of preventative design meant to reduce the likelihood of incident are taken. Because of this, the integrity management program must be organized and operated in a way that ensures that change is detected early and assessed rigorously to determine the threat it poses. With this in mind, I'd like to focus on two of our most prominent integrity subprograms to show how they reflect the concept of continuous monitoring, early threat warning, and calculated repair action. So two of the most prominent integrity subprograms at ATCO are the inline inspection, or ILI, and DIG subprograms. These two subprograms make up a large portion of the Integrity Project Department's annual capital budget, and together they're perhaps the best examples of the pipeline integrity management process for ATCO's operational pipelines. I'll start by briefly describing the activities in each subprogram individually, and then show how one program influences the other, generating a cycle of inspection, analysis, action, and reinspection. I'll start on the ILI subprogram side. So the ILI subprogram facilitates the periodic inspection of ATCO's steel transmission pipelines through the use of ILI tools. These tools come in many different varieties, each meant to be sensitive to different types of damage or deterioration on the pipeline. Some tools are good at detecting and measuring corrosion and other forms of pipe wall metal loss. Others are good at detecting and measuring pipe deformation, like dents. Still others are built to detect and measure cracks. These tools are generally used to inspect pipelines in segments, with each segment consisting of a platform to insert the tool into the line, launch it into the gas stream, have that gas stream carry it through the pipeline, and carry it towards a receiver trap where it is ultimately captured and removed. These tools, as I alluded to earlier, are capable of collecting vast quantities of data about the condition of the pipeline. This data is provided to ATCO in the form of a data log, which is then reviewed and assessed. The information in that data log is compared against code requirements and ATCO's internal acceptance specifications, to determine whether any of the measured anomalies are currently non-compliant, or after growth or change modeling, when they're estimated to become non-compliant. This means that to a certain extent, with the measurements that we do have the ability to predict into the future when threats could become unacceptable. Pipeline reinspection typically takes place every 3 to 7 years, depending on the measured condition of the pipeline and on other risk factors such as line utilization or failure consequence. And on the right side of your screen there, you can see an example of one of the inspection tools. This is I believe it's a 12-inch magnetic flux leakage tool predominantly designed to detect corrosion on our pipeline. Now, the Integrity DIG subprogram is intended to achieve two primary objectives. First one is to excavate a pipeline at targeted locations identified by the ILI program to directly measure anomalies identified in the data log and perform repairs. And two, to verify the accuracy of the data log and to determine whether the reinspection interval should be modified. By now, you can probably start to see how these two programs are closely tied to one another. The ILI subprogram conducts the inspections on the line, which generates the data. That data is assessed and compared against acceptability standards to identify current or future threats. The locations of those threats are then communicated to the DIG subprogram, which conducts digs within the recommended timelines to directly measure the anomalies, complete repairs as required, verify the ILI data log accuracy, and update the recommended reinspection interval. That updated reinspection interval then is communicated back to the ILI subprogram, and after a set amount of time, the cycle starts again. This cycle ensures that in most cases, ATCO is given a long lead time to address new threats to pipeline integrity, and that there is not enough time from the start of one cycle to the start of the next that threats are allowed to get bad enough to be public safety or supply reliability concern. Now, up to this point, I've painted a picture about pipeline integrity that shows a system where data is collected, documented, and reported cleanly and completely from a pipeline's inception through to its operational lifespan. As much as I'd love to say that this is our reality in all cases, unfortunately, I can't. It is true that ATCO's current practices for pipeline construction, commissioning, and maintenance achieve the goals of producing traceable, verifiable, and complete documentation that help make well-informed, unoptimized integrity decisions. But we don't just have modern assets, or even assets that we originally built on our system. Old assets, sometimes referred to as vintage assets in our industry, or even acquired assets, present a unique set of integrity management challenges. We may have records for these pipelines, but they could be incomplete, they could be inaccurate, or they could contain conflicting information. We're also less likely to have a baseline pipe condition data that we can use as a reference, and oftentimes design, construction, and commissioning practices from decades past may not match those that we expect today. How then do we make informed decisions for maintaining these vintage pipelines to the same standard as our modern assets with all the uncertainty that this missing information presents? Again, this is where the integrity management program and its respective subprograms can provide solutions. Given the scale of ATCO's pipeline assets, many of which are vintage, and finite resources, there needs to be a way to identify so-called high priority pipelines, and to do so as accurately as possible without the expectation that we know everything about them. High priority pipelines, for example, may be those that operate in areas of high population density, or maybe they run through areas with significant environmental sensitivity or historical significance, or maybe they act as critical feeds to our various customers. And last but not least, they might have been constructed in such a way that makes them more susceptible to deterioration or damage. ATCO's Pipeline Integrity Risk Assessment, or PIRA, subprogram acts as a hub for this type of work. This program is built to assess our system at all scales, from individual pipe segments up to the entire system at once, and it aims to incorporate everything that we do and don't know about our pipeline system and its surrounding environment. The main information sources include a mixture of historical documents, operational logs, there we go, and observations from work already done on these pipelines by the other subprograms. Pipe age, coating type, manufacturing process, inspection and dig history, cathodic protection data, pressure cycling data, depth of cover, proximity to other infrastructure, surrounding population density, asset utilization and supply criticality, all of these factors and many more play into the assessment process to identify pipelines that have the greatest likelihood and or consequence of failure. The challenge, though, is that these factors have varying certainty from one pipeline segment to the next, and this uncertainty increases risk. Missing or incomplete information, then, is not ignored. Instead, conservative assumptions are made to fill in the gaps. For example, if data about steel pipe grade is missing, the PIRA will default the missing data to the lowest grade. What this does is it achieves two things. One, it treats a lack of information as a risk of its own, which means that a pipeline with missing or incomplete data is ranked as a higher priority than an equivalent pipeline without. And two, it compels ATCO to act and collect or confirm missing or uncertain data in cases where the assessment highlights a segment as being high priority. The results of the PIRA then can inform other programs, and those programs then can focus their efforts on maintaining dedicated attention to those pipelines, ensuring that resources are directed at lines that need them the most, minimizing waste. Most importantly, this process of risk assessment, asset and resource prioritization, and dedicated sub-program action and reporting is done cyclically, much like we saw in the previous slide with the ILI program. This means that new information is constantly being generated that can feed back into the risk assessment, which in turn refines our understanding of where our integrity management priorities lie. This is the benefit of having a multitude of specialized subprograms. We're constantly examining our assets in different ways, and as I've mentioned previously, the interplay between the subprograms creates opportunity to reduce uncertainty through cooperative monitoring and assessment activities and data sharing. Now, in the previous section of the presentation, I touched on just a few of the integrity process cycles that ATCO employs to keep its pipelines happy and healthy for decades. But nothing lasts forever. A good priority management program, pipeline integrity management program, informs a pipeline operator about the ongoing condition of an asset over the course of its life and gives that operator the tools it needs to make sound capital investment decisions, including when it's no longer worth investing in that asset. At ATCO, like any utility operator, our assets eventually age and reach the point where it may no longer be worthwhile to continue normal operation and maintenance. In this section, we'll explore some of the ways that we currently use our integrity program, and especially the data it produces, to inform us about when a pipeline may be due for abandonment or replacement. So, determining when a pipeline asset has reached the end of its life is a challenging issue, and at ATCO, it's one that we're actively refining. We don't currently have a standardized approach or metric that clearly identifies assets as having reached the end of their service lives. Instead, ATCO currently relies on the use of integrity indicators derived from the outputs of integrity management subprograms as possible justification for making an end-of-life call. Some of these integrity indicators include things like a rapid increase in the number of repairs required in the future, typically as a result of ILI measurements and growth estimation, usually within 1 to 2 inspection cycles. So that could be anywhere from sort of 6 to 15 years. Number 2 could be something like indications of a systemic threat to the pipeline asset, such as corrosion or cracking, that isn't localized to one area. In other words, it may become prohibitively expensive for us to conduct repairs at multiple locations in a short period of time versus the value that the asset's providing. And as such, that might be an integrity indicator that says the asset is deteriorating more quickly than we can effectively maintain it. Number 3 could be something like significant integrity management investment requirement on pipelines with low utilization. This could be a case where the cost required to maintain the pipeline isn't being equivalently offset by the revenue that the pipeline is generating. Maybe we don't have much in the way of customers on the line, or demand is dropping. Does it make sense then to increase our asset management spending on that pipeline while our revenue is dropping? So that might be an integrity-related indicator and a business-related indicator that that line has reached the end of its life. And another example might be something like a significant increase in population density surrounding the pipeline asset. And this certainly can be the case. We have a history on our system of looking at and relocating pipelines that are in high population density areas that are of quite significant vintage in some cases, and oftentimes moving those into designated utility corridors for the sake not only of building a new pipeline with modern construction practices, but of also relocating that asset into a location where its risk to the public and the public's risk to it are lower. And this just represents a couple or a few examples of the types of integrity indicators that we might look at when we're trying to make the decision about whether or not a pipeline has reached the end of its life. In general, though, these integrity indicators act as the first signs that more in-depth analysis is required to decide whether to begin transitioning the pipeline into its end-of-life management phase. So if we do conduct that assessment or that review, and we find that these indicators result in a decision to consider the asset at the end of its life, the program then transitions that asset from regular operational integrity management activities to end-of-life activities. This usually means that ATCO will no longer undertake more costly, proactive integrity management procedures, and will instead only conduct those procedures required to maintain safe operation until the asset is removed from service. Some options for end-of-life integrity management include things like permanently reducing the operating pressure on the line, creating dig and repair plans that target only the most critical integrity threats, typically based on how much time the asset is estimated to be remaining in service, and localized abandonment, especially in cases for assets with low utilization. If there are legs or stretches of a pipeline that are what we would call dead legs, in other words, there's no flow on them or no delivery or receipt that they're collecting or delivering gas to, we might be able to abandon them completely and reduce the total length of the system, which has an effect on reducing the total risk as well. Eventually, the asset will be removed from service. If the decision was made to replace or relocate the pipeline, the existing pipeline will usually be decommissioned and abandoned. Pipelines may also be abandoned without replacement, such as instances where utilization is low. ATCO may also elect to divest a pipeline asset through sale to another operator, but this is pretty rare. If an asset does end up being abandoned, it is typically abandoned in place. What's interesting, though, is that from a regulatory perspective, a pipeline that has been abandoned in place, in other words, one that is no longer in service, but the physical pipe is still in the ground, that actually a type of abandonment and that type of pipe is treated much like an operational pipeline. So in this case, that means that when third parties want to cross the line or excavate over or near it, the same type of approvals and permitting processes must be followed, and the line must be located prior to ground disturbance, even though the line isn't in service. This means that while this form of abandonment is relatively economical, it comes with a set of post-decommissioning requirements that continue until the asset is physically removed. Now, at this point, once the pipeline has been fully decommissioned and it's been abandoned, it really isn't a part of ATCO's integrity management program, and it's not actively undergoing any maintenance activities. If a new pipeline is built in its place, though, that integrity management life cycle for that new pipeline begins again, and the process starts all over, and we continue managing that new asset as we had the old. All right. As we near the end of this presentation, I'd like to reflect on what was covered and highlight some of the key takeaways about ATCO's integrity management program. Our integrity management program is structured to inform decisions and influence best practices across the entire pipe life cycle. And in this case, it influences the decisions made during the design, construction, commissioning stage to reduce the likelihood of failure from integrity threats through preventative measures, thereby making the pipeline more resilient and more reliable over time. It utilizes various interacting sub-programs to monitor change, to warn of threats early, and to prioritize and adjust maintenance activities over the course of the line's operational life. And 3, it provides a platform to identify pipeline assets that are nearing the end of their lives and to evaluate ATCO's alternatives for managing them until they're ultimately removed from service. With the program in place, ATCO puts itself in an excellent position to ensure long-term system reliability and resiliency, to manage the ongoing uncertainty of operating pipelines out in the world with incomplete data or with ever-changing circumstances, and ultimately to protect public safety. Thanks.
Excellent, Brendan. That was a great presentation. So yeah, no, that's good. There's lots of questions here. And if there's any additional questions, please put them in. We'll start with a few here to kind of get the discussion going. We'll see where it goes. How about we start with something like, given that many integrity actions taken during the operational phase of the pipeline are reactive, how do you ensure that threats are identified early enough?
Yeah, that's a really good question. Sometimes that can be a little bit difficult, especially if we're dealing with older assets that may be undergoing new types of inspection for the first time. But I'll focus predominantly on assets that we have good history with, so that we can kind of get a good example of that. So, as I'd mentioned in the presentation, part of the process is making sure that reevaluation cycle is short enough that significant change isn't allowed to occur. So as I mentioned, like for example, with our inline inspection program, we typically reinspect those lines every 3 to 7 years. And that really is about making sure that there isn't a big enough interval of time that corrosion or something like that could grow and could get worse to the point where the next time we inspect it, we're a little bit scared by what we see. So part of that is about the interval and making sure that the interval is appropriate. The second part of that would be the interaction between subprograms. So the idea is that in some cases, there may be indirect indicators that there is an integrity threat occurring on the line. So, for example, one of the things that we sometimes look for as indirect indicators for cracking would be things like shallow corrosion clusters on pipelines with particular types of coating. We know we're more susceptible to this sort of thing. If we see that, even though we may not have directly detected cracking, we might use that information as justification to say, hey, we need to go and check to see if, in this case, stress corrosion cracking, which is the particular type of cracking that we're thinking about, whether or not it's initiating, because there's that indirect indicator that could be a possibility. So again, the benefit there is that if you measure the line in various different ways, even if you don't directly measure a threat, you might be able to measure its precursor or some indicator that suggests that threat is imminent or could already just be beginning. And that's another way. If you get really good at looking at the patterns, that's another way that you can find and address some of those threats earlier than you might otherwise be able to do.
Cool. Here's a good one for you. How is pipeline integrity management evolving with digital tools, sensors, or AI-based predictive maintenance?
That is a great question. Yeah, I would say it is constantly evolving. What I might be able to do is I can give a bit of an example looking at maybe some of the history of inspection technologies and talk about the evolution over time and sort of discuss how that is even looking forward into the future. So again, we'll go back to inline inspection. Inline inspection tools in some shape or form that are capable of actually scanning, monitoring, and collecting that data have been around for, I think, over 50 years now. What we've been doing is we've just basically been taking that basic format and adding new tools that can detect new threats, new technologies, et cetera, onto the platform over time. So, for example, we went from the ability to really detect basic metal loss features to begin with. 20 years later, we added, in the case of natural gas, we added tools that are capable of detecting cracking with reasonably high accuracy. And now, there are discussions about adding tools that might even be able to detect other features that we struggle to detect right now. Improving cracking detection, especially on gas pipelines, is particularly difficult. What I've noticed, even over the course of my career, is the quality and the quantity of data that we can collect with these tools. So I mentioned the data log that I was talking about. Even 10 years ago, those data logs looked different than they do now. There's simply a larger database of anomalies out there that our vendors that are responsible for managing that can reference, which means they can make better calls about what it is that they're seeing in the data. And that gives us the ability then to make better decisions. It's not uncommon right now for our vendors, when they are looking at that raw data assessment and translating it into that data log, to use a combination of machine learning and human intervention in terms of screening, classifying, categorizing, and reporting. So there's already, and for several years this has been the case, there's already a mixture. And part of the reason for that is simply the volume of data that needs to be addressed. It isn't feasible for a human or a set of humans to look at that data in high quality and do it over a large scale. So those machine learning systems are really great at that, especially given the training data sets that they have, which are vast. Now, looking forward, I think that there's a lot of push in industry, especially on the vendor side, to incorporate artificial intelligence into the equation, especially to be able to more accurately identify patterns that may be really subtle in the data, but that could have significant consequences for us as operators. The last thing that we as operators want is to have something be missed that ultimately fails. And so any tool that comes to the table that gives us the ability to detect patterns that might have otherwise been missed due to their subtlety or their complexity is extremely valuable. And I think that's probably one of the big areas where digital technology is going. On the sensor side, it's all about miniaturization and resolution. So we're actually in the midst right now with inline inspection tools of a bit of a generation shift. The way I describe it is we're kind of going from HD to 4K in terms of the sensor density and the resolution that the tools are capable of providing us, which is unlocking new sort of layers of ability to visualize our pipelines simply because we can just see at smaller scales. So that's ongoing as we speak. We've got fleets of these much higher resolution tools that are actively being built out now, and we've already started using them on our system. So hopefully that covers that one. I mean, there's a lot of different ways that we could go with that, but I think that kind of covers the hardware and the software side to a certain extent. No,
that was good discussion. Very good. I'm gonna throw one at you here. I'm not sure if this is within your wheelhouse, but we'll see. Question here about, are abandoned pipelines ever reused or sold to be used for other purposes as conduit for other utilities going forward?
I would say yes, with a bit of a caveat. So typically when we are abandoning pipelines, one of the things that we would do is we would try our best to fill them in, usually with like a grout-like material. And that just helps stabilize them over time, because the expectation would be that if we're no longer actively managing them from a corrosion perspective, maybe we're disconnecting our cathodic protection system, we're not monitoring for coating damage, that line is eventually, given enough time, it's going to rust away, it's going to disappear. And so in order to make sure that we don't have a rut form in the ground where that pipeline used to be, we usually fill them with usually like a grout-like material. What I would say is not so much abandoned pipelines, but we do have a classification which I would call discontinued. These might be pipelines that are not actively in service, that would have a licensed maximum operating pressure that would be dropped down to 0 from a regulatory perspective, but they're not necessarily abandoned. In other words, they could be reactivated at any time. And in fact, we have a history of doing this on some of our pipelines where demand has increased, or we maybe realize that we need an alternative throughput option for getting gas to a particular location. We just happen to have an asset in the ground already that can do it. So I would say it's relatively rare, but it can happen for these discontinued pipelines that haven't gone through the full abandonment process. And I will add that it's not simply a case of turning the gas back on and repressurizing the pipeline. These discontinued pipelines must undergo a comprehensive engineering assessment. They typically must undergo another hydrostatic pressure test. And so in other words, it's not too dissimilar to bring a discontinued pipeline back into operation as it would be to commission a new pipeline. The only difference is you're not building it in the first place. It's already there.
Yeah. Okay. I've got a couple design kind of questions here. This one, yeah, let's see where we go with this one. This was, we're talking a lot about steel pipelines. Why do we not use high density polyethylene?
That's a great question. So we do on our distribution pipelines at lower pressures. So one of the things that might be really important to discuss here would be the difference between our transmission pipeline system and our distribution pipeline system. So natural gas pipelines operate in a very similar way to our electrical grid. In other words, for transporting natural gas over long distance, similar to an electrical system, you need high pressure, or in the case of electrical, high voltage transmission lines. That's just the most efficient way to transfer the material over long distances, to overcome friction losses in the pipeline, and to make it economically feasible. When the gas reaches its destination, it is then stepped down in pressure. It's regulated down to a lower distribution pressure, which is then able to transport it into the customer's location, whether that be a house or a business or something like that. similar to what we would have on the electrical distribution side, right? We're not pumping our houses with 250,000 volts of electricity, and we're not pumping our houses, in the case of natural gas, with gas that could be at 5,000, 6,000, 7,000 kPa as a pressure. So really, again, it's about the economics of how does the gas need to be transported and where, over what distances. So high-density polyethylene, as far as I'm aware, is not suited to handle gas at transmission pressure, but it's perfectly suited to handle gas at distribution pressure, which might only be at most, or at on the order of a few hundred kilopascals. So that's the primary difference. When we're dealing with the pressures that we're talking about on the transmission system, steel is by far the best option.
And then building, it's a really good analogy actually between the electrical and the gas. I know you guys do both, but that was a good analogy there for sure. That's good. When you're in the design phase of the pipeline, there's so many different variables in terms of design. What are some of are you able to comment on maybe some of the design choices that might have the biggest long-term impact on integrity of a pipeline?
Sure. Yeah, absolutely. Well, I mentioned one of them in my slide already, and that's coating decision. So, over the years, we collectively as an industry have experimented with different coating systems as new technologies have become available, and as we've come to a better understanding about really what works and what doesn't in terms of being an effective physical barrier between the pipe and its surrounding environment. So a perfect example of this would be, in the 1960s and 70s, we moved from sort of older coating systems to a system that involved the installation of polyethylene tape on the pipeline. And at the time, it was seen as a really economical and fast way of providing what they thought was a durable, waterproof coating that, in their minds at least, was effective both from a corrosion management perspective, but also from a cost perspective. Well, fast forward 40 to 50 years later, we realize that, no, that was actually a terrible decision. Not only does the adhesive of these coating, of that polyethylene tape coating deteriorate over time, but the polyethylene itself can embrittle, which means that it can flake off, it can disbond from the pipe. And that leads to problems with our cathodic protection system. That leads to the ability for water and sediments to get in and come in direct contact with the pipe. And all of those together can lead to accelerated, and in some cases, very aggressive corrosion on the pipeline. So obviously, we don't do that anymore. Polyethylene tape is not an option for us on mainline coatings anymore. But we have moved and advanced that coating world now to a point where these are high performance coatings that are significantly more resilient, more durable, we hope, over the long term than coatings of past. And that, while maybe the upfront cost is a little bit higher, the expectation is that it means that 10, 15, 30, 50 years from now, it pays for itself multiple times over in all of the repairs we won't have to do. Other examples of design considerations that maybe have the largest impact have a lot to do with the physical attributes of the pipe itself. So again, if we're just talking about steel, one of the biggest things that we can do to make steel pipe more resilient to integrity threats is to just make it thicker walled. So in other words, have more wall of that steel pipe, more physical material to work with. And the way that I see it is that benefits us in two ways. One, from a corrosion perspective, it means there's just more material that corrosion has to get through before it becomes a concern. And two, depending on the diameter of the pipe, it can actually reduce the pipe's susceptibility to deformation, things like denting, for example. It actually makes the pipe more rigid and more difficult to deform. So both of those, things that we contend with every day from an integrity management perspective, corrosion and deformation are the two most common flaws that we find on our pipelines by country mile. And so something as simple as increasing the wall thickness of the pipe can have long-term benefits from a resiliency perspective in that regard. Just to name a few, there's many, many more.
No, that's really good. And I guess just really briefly, I guess I've always in my head been thinking here that this is a long-term kind of, you're looking at big data and you're looking at corrosion type stuff and other factors, but the deformation is interesting because those are things that could be occurring tomorrow, where somebody's doing a line hit or something like that. So
exactly.
So moving on to that discussion from like a line hit perspective, do you guys get involved in terms of assessing the damage fairly immediately at that point if there is a line hit?
Yeah, I guess there's sort of two ways that we can find out that a line hit has occurred. One is that the organization or the individuals that hit the line report it, yeah, which is what we would hope and expect to happen. It doesn't happen all the time. The other one is, because it doesn't happen all the time, we conduct inspections on the pipeline, ILI tools, for example, and we find those dents with, let's say, gouges in them that are the absolute smoking gun of an excavator bucket tooth impacting our pipe. So in instances where the line hit is reported, integrity would be one of sort of two departments within ATCO that would focus on that. We also have what we call our operations engineering department, which is specifically geared towards what I would call sort of more urgent or emergency related incidents like line hits or leaks or that sort of thing. But integrity can get involved to assess, how much time do we have? What repair options should we consider? Maybe we want to, test if we're going to cut that piece of pipe out. Maybe we want to send it off to a lab to get tested and see, how did the material fare? Where integrity is significantly more involved would be in the cases where the line hit is detected indirectly. So we've done some inspection work and we've found evidence that somebody came in here and didn't report it. At that point, then, we really need to assess it because we don't know how long it's been there. We don't know, whether or not it's the only one. And so we need to start saying, is this a threat that is imminently of concern, or do we have a little bit of time to plan our repair and do whatever we need to do? And that also then has impacts on things like, how is the line going to operate during that time? Do we need to reduce the pressure to reduce the likelihood that maybe if there's a crack there, that it could fail? All of those evaluations are done by the integrity team.
That's pretty good. Okay, we're kind of at the top of the hour, so we're going to wrap it up. So I got one more question for you.
Perfect.
This is kind of maybe expanding beyond the pipeline realm, but what's one takeaway from pipeline integrity practices that could strengthen how we manage other buried infrastructure?
Oh, that's a great question. There's so many things going on in my head, but I would think, yeah, I know. I'll try and keep it to one. I think the biggest one here is management of uncertainty. So I alluded to that as an issue that we contend with, and sort of what we're doing to overcome that. Look at, analyze our asset from as many different angles as possible, as frequently as practical. And we give ourselves the best shot at finding problems before they become an issue, right? But also just really being able to keep close tabs on change over time. We also get really good at pattern recognition, right? We might be able to, the more that we do this, we may be able to see patterns that could give us an extra year lead time, for example, in addressing a problem. Or maybe we could find patterns that say, hey, we need to modify our design directives to make this aspect more resilient because it's always the source of failure. Is there a way that we can modify the design out at the outset to make that particular source of failure less likely to occur? So I think it's that management of uncertainty. It's that management of change through a multifaceted data collection process at an appropriately high frequency that can answer a lot of questions and keep us absolutely on top of our assets.
Excellent. That was maybe a little bit of a curveball. That was really, really well done. No, really great presentation today. Excellent Q&A. Really appreciate you being here today. And thank you very much.
Yes, thank you.
So yeah, we'll just wrap up here again. Thank you very much, Brendan, for being here. Thanks for all the members being online here today, and thanks for all the other attendees. And we hope to see you here next month for the next CUIIC webinar. Have a great day, everyone.